All right, today, just a little warm up here for you. Obviously, you're not going to have this discussion since we were doing this on a video instead of in class. But I do want to talk about, just to give you guys a little refresher of what a function is. If you guys remember back to, I think it was the end of chapter 1, we said that a function was something where every input has exactly one output. And the key word here is we have exactly one. So it can't have more than one. It has to have exactly one. It can't have 0, can't have anything else. It has to be exactly one. So today, we're going to talk about functions and relations. So a relation is going to be any set of ordered pairs. So we've got a couple different ways for us to talk about those relations. Usually it's going to be a graph or an input-output table, those things that we talk about. And it could just be actually a list of ordered pairs as well. But we're not going to worry about those a whole lot today. So first thing we're going to do is we're going to determine whether the following relations are functions. So in A, I look at my inputs. Well, this is called a mapping, if you remember. And each input right here, input of 1 goes to 2, input of 2 goes to 4, 3 goes to 4, 4 goes to 5. So this is okay. We're going to classify this as a function. Because each input has exactly one output. But you're saying, hold on here. 2 and 3 both go to 4. That's okay. The key here is that each of our inputs only goes to one number on the output table. So if we look at problem B here, we see that 1 goes to 5 and 1 goes to 7. Right there, that's enough for us to say, whoa, we got a problem. So this is not a function. Because 1, the number 1, has 2 outputs. Then, going back to 4.8, we talked about the domain and range. The domain is going to be all of our input values. So, just a refresher on how we list those. Put them in your curly brackets. Your domain, again, all your inputs. So, we're looking at 1, 2, 3, and 4 back in problem A. And our range is going to be all of our outputs. So 2, 4, and 5. Our inputs for B, we're going to have the same domain. So 1, 2, 3, and 4. And our range, those are all of our outputs, 5, 7, and 9. Even though it's not a function, you can still list the domain and range for problem B. Then, the questions that we really want to answer today is, if we look at a graph here, is this going to be, are these going to be functions? Well, our inputs are going to be our x values. So, if I look at the figure on the left, this nice curvy line, not the oval, it's hard for me to tell whether either one of them are. So, what we're going to do is, you guys may have seen this. Hopefully you guys have seen this before. It's called the vertical line test. So, if you take a vertical line and you slide it through your graph, if it touches 2 or more points, then it is not going to be a function. So, if I draw a vertical line, and I'm going to make it red so we can see this nice and easy. But if I get a vertical line, it can be any vertical line you want. Your pencil works well for this. Okay? So, if I slide it through my graph here, it doesn't hit 2 points here. But if I go over to this sideways deal here, you can see that as I slide it, I'm hitting 2 points all over. I don't want to move the picture. I just want to keep moving my line. So, if I go to the S here, obviously I hit in a whole bunch of places. So that's not going to be a function. But these first two are going to be functions. So we're going to take this with our vertical line. Let me get another one here. And let's see what we can do. So I'm going to draw a nice big one here. Make sure that I can cover all of our graph. So if I slide it here, well, as I go, I slide. I'm not touching any points, not touching 2 points. No, 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 no. And, well, it looks like this one is going to pass. So, this is going to be a function. It passes the vertical line test. And let's take a look at our oval here. You guys may already be able to see what's going to happen here. But I slide. I touch 2 points on the graph at the same time. So I'm touching right here, and I'm touching right here. So that, of course, is enough for me to say this is not a function. Because it fails or does not pass the vertical line test. So that's the vertical line test. That's really easy. If we have graphs, we can use that to help us determine if they're functions or not. The last thing that we want to talk about today is going to be what we call function notation. Okay, this is purely notation. So you can see here, I've got this fancy f with an x in parentheses. That's just going to take the place of our y. It's not going to serve any different purpose. It's just a different way for us to write it. This function notation works really well when you have different functions that you're working with at the same time. So you could instead call one f, one g, and one h if you're working with 3 different ones. It's read f of x or the value of f at x. So it is not multiplication, and we'll get into that. So the way we talk about functions a lot, at least to introduce them, we talk about them as a function machine. So the whole deal with the function machine is if you input an x, you run it through the function machine, you should be able to know exactly what you're going to get with this output. So if I have my function, f of x is equal to 2x minus 3. Well, I know that if I say instead I put in x equals 3, okay? This works the same way where everywhere you see an x, you're going to insert a 3. So you're going to put f, the value of f at 3 is going to be 2 times 3 minus 3. And your value of f at 3 is going to be 6 minus 3, or 3. Okay? The key is once you get to this point right here, I know a lot of you are going to look at that and say that that is f times 3. And you're going to try and solve for f by dividing. Do not divide by 3. Okay? Stop here. Okay? This is just notation. This is saying that our function f, whatever it is, evaluated at 3, is going to be 3. So, I see a lot of people that'll try and divide and say that f is going to be 1 by dividing both sides by 3. No. Stop right where we stopped here. Do not go farther. So, what they're going to have you do is they're going to say evaluate the function for the given value of the variable. So, hey, f of x is 2x minus 3. That works out nice. We just worked with that. We want to evaluate it at x equals 0. So, just like we did, we're going to plug in a 0 everywhere we see an x. So, we're going to have f and then 0 in parentheses, 2 times 0 minus 3. On the right-hand side, that is still multiplication. So, f evaluated at 0 is 0 minus 3, or negative 3. Okay? And that is where we want to be. So, that's your answer right there. Okay? We've got a different function here. G of x is going to be negative 5 times x. This one here, you're going to plug in 0 here. You're plugging in 0 here. You're going to get g evaluated at 0 is going to be negative 5 times 0, or g, the value of g at 0 is going to be 0. Again, stop right there, keep it right where it is, and we will be a-okay. So, here's your homework, page 260, number 11 through 19, 21 through 25. Try and work through those a little bit. If you have questions, shoot me an email, let me know. I'll do my best to answer as much as I can. Hopefully this made sense. Hopefully this helps you guys. We can clear up anything on Monday that we need to. So, that's all I have for you. Thanks for watching.